Everyone. Today's topic is PLL. PLL. So in previous phase lock loop definition, and also the block diagram of phase lock loop. The block diagram of phase lock loop, it contains mainly 4 blocks. First one is the phase detector, or it is also known as phase comparator. Next one is the low pass filter, followed by amplifier, and the last one is VCO. VCO stands for voltage controlled oscillator. So PLL, the main advantage of PLL is a closed loop feedback system. The feedbacking is nothing but a direct connection established from output to input. These are all we are discussed in previous class. And also circuit description. So just we have a connection from phase comparator to low pass filter, or the output of phase comparator will be given to input as a low pass filter, and the low pass filter output will be given to input as VCO, or it is input to the voltage controlled oscillator. And the feedbacking from voltage, the output of VCO will be given to phase comparator. So the PLL, it work on 3 conditions, or it will be work on 3 modes. First one is the free running mode, second one is the capture mode, and third one is the lock range. When phase lock loop, lock range is the third one. Whenever no input is given to the phase detector, it is called free running mode of operation. When we are given input to the phase detector, the VCO will monitor the phase detector input. This is called capture range. Whenever the VCO output frequency is equals to input of phase detector, then it is called lock range. So VCO continuously change the output frequency. Voltage controlled oscillator continuously change the output frequency unless it will be equals to input frequency. Then only it will be is on locking mode, phase locking mode. So these the topics we are completed in previous sessions. Phase lock loop, phase detector, comparator, or it is also known as low pass filter. The main advantage of low pass filter is using here in this block diagram is the low pass filter. The advantage of low pass filter is nothing but it removes the high frequency components. At the same time noise will be reduced, high frequency reduced and noise also reduced. And low pass filter will be followed with amplifier. Our low pass filter next session is amplifier. The main advantage of amplifier is increasing the gain. So by using of low pass filter, we can reduce the high frequency components as well as noise, and the gain will be increasing by using of amplifier. The output of low pass filter will be given to input to the VCO. So this is all about phase lock loop. Phase lock loop applications. It will be used in speed control motor. Next, also it will be used in FM demodulators. So next, this is the previous classes. Already we are completed timers, timer block diagram, that 555 IC. Next, multi-vibrators. In multi-vibrator we are completed a stable multi-vibrator and monostable multi-vibrator. Next, phase lock loop. And today's class is in 5th unit. Now we are discussing Pll-Lm pin diagram of Pll-Lm first. So in this class we are discussing about pin diagram, at the same time block diagram of PLL. First we are discussed with pin diagram, or first we are starts with pin diagram of Pll-Lm. This is the pin diagram of Pll-Lm. This is the pin diagram of Pll-Lm. In Pll-Lm we have 14 pin configuration. The 14 pins are connected in a DIP package. DIP stands for dual inline package. Here one side dual inline. dual pins are connected in a lines. So we are using this IC as a 14 pin IC. The 14 pins are, first pin is negative, second, third is input pins, and fourth pin is VCO output. The VCO stands for voltage controlled oscillator, and the fifth pin is here using fifth pin is input to phase detector from VCO. So VCO output is given as input to phase detector from VCO, and sixth pin is the reference output, seventh pin is the demodulation output, eighth pin is the external R for VCO. External R is nothing but external resistor of voltage controlled oscillator, and the ninth pin is external capacitor of voltage controlled oscillator. 10th pin is positive supply. First pin is negative supply, that is at the ground. 10th pin is positive supply. 11, 12, 13, 14 pins are, the remaining 4 pins are no connection, not connected pins. So 1 is for negative supply, ground connection, 1, 2 and 3 for input sessions, and 4th one is the voltage controlled oscillator output, and 5th one is the input to phase detector from VCO, 6th one is the reference output, 7th one is the demodulated output or demodulation output, external R for VCO, external C, and the positive supply. The remaining 4 pins are not connected pins. This is the 14 pin diagram of LM565. The 14 pins, it consists of 14 pins and it will be arranged in a dual inline package. The 14 pins, 7 pins are one side and the remaining 7 pins are in another side. Let's say next, block diagram of PLL565. So block diagram of PLL565, it contains first phase detector. The phase detector, it contains the input as 2 and 3 phase detector. Next, amplifier. The next phase detector will be followed with phase comparator VCO input, and fourth pin is the VCO output. Eighth pin will be connected to external resistor. Ninth pin will be connected to external capacitor. 8th pin is external resistor, 9th pin external capacitor. Pin number 1 is connected to negative supply, 10 will be connected to positive supply, 7th pin will be connected to demodulated output, and 6th pin is connected to reference output. The demodulated output and reference output will be, demodulated output will be followed with resistor to amplifier. Next, reference output will be the output of amplifier. Next, here we are using low pass filter. Next, positive supply pin is 10th pin. Phase detector has 2 inputs. One is the input 2 and second one is the input 3, and it also given to phase detector for phase comparator VCO input is also given to phase detector, and the VCO is nothing but voltage controlled oscillator. The 4th pin, the VCO output is the 4th pin, and 8th pin is the external resistor, and 9th pin is the external capacitor. This will be in block diagram. So block diagram working function later we are discussed. First, pin configuration of 14 pin dual inline package first we are discussed. Now I am discussing about PLL565 IC available 14 pin dual inline package. So input pin, the input pin is nothing but first first VCC negative power supply input pin. Next, input pin is nothing but phase detector input. This is the phase detector input. Phase detector input. Phase detector input. Next, phase detector FM signal input. Next, VCO output. VCO output is here VCO voltage controlled output, and the 5th pin is the phase comparator output. Phase comparator VCO output. The phase detector input pin VCO is nothing but VCO output is the feedbacking to pin. Next, VCO is nothing but voltage controlled oscillator output pin. Next one is the reference output. The internal amplifier reference output. Here this is the reference output. Pin number 6, reference output. 7th one is the VCO controlled voltage. VCO control voltage can be seen at this pin. Next, Timing resistor is nothing but resistor for free running frequency of VCO. Timing capacitor for free running frequency of VCO. Next, positive power supply. Pin 10 is positive power supply. 11, 12, 13, 14 are no connection pins. So first pin is nothing but pin 2 or 2 and 3 are used for input pins, and fourth pin is the output pin. Next, fifth pin is the phase detector input of VCO, that is nothing but VCO output is feedbacking pin, and next one is the reference pin is sixth pin. Next, VCO controlled voltage is nothing but seventh pin. Next, timing capacitor, timing resistors are 8th and 9th pins. 10th pin is power supply. 11, 12, 13, 14 are no connection pins. This is all about pin configuration of 14 pin dual inline package of Pll-565 IC or LM565 IC. Next, LM565 is a general purpose PLL, general purpose phase lock loop IC. It will be used, or it is designed in purpose of demodulation and frequency multiplication and frequency division purpose. The main advantage of LM565 PLL is LM565 is one IC. It works as a phase lock loop, and it will be designed for the main aim of 565 IC is frequency modulation, first designed for demodulation, frequency multiplication and frequency division. Next, the device, it consists of mainly two components. One is voltage controlled oscillator, that is nothing but VCO, and another one is the phase detector. The phase detector inputs are 2 and 3. So here we are consist of two phase detector, at the same time voltage controlled oscillator. Next, so here two components are mainly the two components are phase detector, and another one is the voltage controlled oscillator. Next one is in VCO is designed for highly linear operation and phase detector with good carrier suppression. So phase detector, it is also known as fade comparator. It is used to good carrier suppression purpose, and VCO is used for linear operation. Linear is nothing but the output which follows the input circuits are called linear circuits. Non-linear circuits is nothing but output which not follows the input is called non-linear circuits. Next, so manam here we have discussed LM565 applications mainly used in demodulation, frequency division, frequency multiplication. The two main parts are phase detector and phase detector and VCO. VCO is linear purpose and phase detector is used for carrier suppression purpose. Next, LM565 IC is used in the LM565 basically used in applications where a PLL is used, such as FM demodulation and signal frequency divider, multiplier. The device is specially designed for only high linear VCO for the low distortion FM demodulation, and the device will be cheap and it can be used in applications where the cost is considered. So the cost of device is less, so less cost of it will be used in maximum applications like demodulation, frequency division, multiplier, and it contains the highly linear VCO, that is nothing but output which follows the input. Next, here we are using RT. RT is nothing but external resistor which is connected to pin 8. So the recommended value or the external resistor value will be between 2 kilo ohms to 20 kilo ohms. So RT is the external resistor which is connected to pin 8. The value of external resistor is from 2 kilo ohms to 20 kilo ohms. CT is nothing but external capacitor which is connected to pin 9. So the pin 9 and pin 1 external capacitor. Low pass filter, it is a RC circuit in which capacitor C is connected between pin 7 and pin 10 supply terminals, and also internal resistance, that is resistor R is 3.6 kilo ohms, and the resistor which makes the low pass filter. Low pass filter is nothing but it will be designed by using of RC circuit. RC is nothing but resistor capacitor circuit. So the capacitor will be connected between pin 7 and pin 10. So pin 10 is nothing but supply terminal. Here also capacitor will be connected between pin 9 to pin 10. Here the capacitor will be connected between pin 10, and the internal resistor value here we are using 3.6 kilo ohms, and the capacitor and resistor which makes the low pass filter, internal resistor and capacitor which makes the low pass filter. Here the resistor and capacitor, the two resistor and capacitor which makes the low pass filter. Next, the resistance value is 3.6 kilo ohms. Here the low pass filter will be connected between pin 7 to pin 10. The pin 7 to pin 10 connection is capacitor, C2 capacitor, and it will be followed by 3.6 kilo ohms resistor. So it works as a low pass filter. And the low pass filter will be designed by using a RC circuit. The capacitor is connected from pin 7 to pin 10 supply terminals, and the resistance value is 3.6 kilo ohms. The capacitor and resistor makes the low pass filter. Next, the output of voltage controlled oscillator is taken across the pin 4. So the VCO output is connected to the input of phase detector or phase comparator, that is pin 4 and pin 5 are shorted. So our VCO output will be taken across pin 4, and the VCO output is connected to input of phase comparator. The phase comparator is nothing but pin 4 and pin 5 are short circuited, and voltage controlled oscillator frequency will be adjusted with changes of RT and CT values. So voltage controlled oscillator frequency adjusted by external resistor and external capacitor. RT CT stands for external resistor and external capacitor. Next, VCO will be adjusted with pin 8 and pin 9. Pin 8 is external resistor and pin 9 is the external capacitor. And the next one is the low pass filter. The function of low pass filter is to remove the high frequency components in the output of phase detector, and also it removes the high frequency noise. So we are already know the low pass filter characteristics. The main characteristics are, the main advantage of low pass filter is nothing but it removes the high frequency components of the phase detector, and also removes the high frequency noise. Next, circuit description of Pll 565. This is the circuit diagram of Pll 565. Just now we are discussing about Pll 565 circuit operation, how it works, how it can work. So here we are using the device pins. In the device pin 2 and pin 3 are the input pins, where we can connect the input analog signal, but usually pin 3 will be grounded and pin 2 used as a input. But practical cases, pin 3 will be connected to ground case and pin 2 will be connected to input. Next, pin 2 and 3 are input. We are connected the input as a input analog signal. The analog input will be connected to pin 2 and the pin 3 will be connected to ground case. Next, the input signal goes to the phase detector. The phase detector is also known as phase comparator. So the phase detector compares the phase or frequency, compares the phase difference, or it also compares the frequency. So it compares the phase or frequency difference between input signal and VCO. Here the VCO signal is feedbacking signal, VCO output. So phase comparator VCO input, by using a fifth terminal we can give the phase comparator input to phase detector. So phase detector, it contains three values. One is the input 2 and input 3, input 5. Generally input 3 will be connected to ground case. Just the phase detector contains the input of pin 2, and at the same time phase comparator VCO input, voltage controlled input, through pin 5 configuration. So the phase detector, it compares the phase or frequency difference between input signal and VCO, voltage controlled oscillator. Next, the produced DC voltage is proportional to the difference value. So the difference value, the DC voltage is amplified and it will be applied through low pass filter to the control input of VCO. Next, it produces a DC voltage and it will be proportional to difference value. Next, the DC voltage is amplified. The produced DC voltage is amplified by using of amplifier, and it will be applied to low pass filter to the control voltage of VCO. Here low pass filter, it removes the high frequency components and it will be given to control input of VCO. Next, the voltage adjusts the output frequency of VCO. So the DC voltage which is given to low pass filter and it will be next given to control input of VCO. The voltage will be adjusted output frequency of VCO until it matches the input signal frequency. So when the two frequencies is matched, the phase lock is been established. So the locking mode is nothing but the input frequency is equals to output frequency, then only the locking mode is arises. So first DC voltage is applied to low pass filter to control input VCO. So the DC voltage adjusts the output frequency of VCO. Why it can adjust is nothing but the VCO, then only just the output frequency will changes in the VCO, then only it matches to the input signal frequency. When the two frequencies, that is nothing but output and input frequencies are matched, then the phase lock loop will be established. Next, if the input frequency changes, the output of the phase detector changes, thereby forcing the VCO frequency to track the input signal. So whenever we are changing the input frequency, the output phase detector also changes, thereby forcing VCO frequency of input signal. The output of VCO is nothing but F0 is equals to 0. Output F0 is nothing but output frequency. F0 is equals to 0.25 by RT. RT is nothing but external resistor value. CT is nothing but external capacitor value. So here the output in terms of frequency, the units of frequency is hertz. So the output frequency F0 is equals to 0.25 by RT into CT hertz. Next, same circuit we can explain in another procedure. Circuit operation in another procedure. First, same, the input signal is given to the phase detector along with VCO feedback and the phase comparator. It compares the both signals are in same phase, are in same frequency. If they are in same phase, the PD stands for phase detector. The PD provides 0 voltage and output if is phase 0 voltage output, and if phase frequency present in the voltage of PD is given to amplifier. So it will be difference and it will be given to VCO. The VCO is nothing but the output of phase difference is nothing but, or the output of phase comparator is given to amplifier. The amplifier is used to amplify the voltage signal. Next, and the amplified voltage signal is given to VCO. VCO is nothing but voltage controlled oscillator which generates the waveform whose frequency depends on the magnitude of given input voltage. First, the both input value and the VCO value will be same. The phase detector, it gives the value as a 0, or it compares both signals, input signal and VCO. So both are in same phase and equal value. If they are in phase, it provides 0 value. It will be different, it provides the value. Voltage and output are, if phase or frequency is present, the voltage is given to amplifier, just it amplifies and given the VCO. Next, VCO is nothing but whose frequency depends on the magnitude and given input voltage. Next, now consider the no input is given. Under such cases, the VCO will be free running mode, generating signal. Free running mode is nothing but no input. VCO will be in free running mode, generating signal whose frequency will be determined by the capacitor and resistor. In free running mode, the frequency of the signal is, the frequency of output is determined by external resistor and external capacitor. Next, when the signal is given at the input, the frequency of both input signal and VCO output is compared, and if they are not matched, the phase detector provide a voltage which is amplified and fed to VCO. So the VCO will increase or decrease the signal frequency depending upon the fed voltage amplifier. Once the adjustment adjustment is done, both the signal frequencies and the VCO frequency will be matched. So first case, no input is given. Whenever no input is given, the frequency will be determined by using of external resistor and capacitor. When we are applying input to pin to terminal to phase detector and VCO output also given to phase detector or VCO. Next it compares. The comparison value will be difference. So it adjusts the VCO adjusts the frequency until unless it equals to input signal value. So it will be, then only it will be locking. This is a phase lock loop works. VCO output signal frequency always tries keep with the input signal frequency. So always try to keep with same as input signal frequency. Next, applications. The main applications of LM565 is FSK and FM demodulation. FSK stands for frequency shift keying. Frequency shift keying and FM demodulation. Next, data and type synchronization. Next, modems. Modem is nothing but modulator and demodulator. So frequency shift keying and FM demodulation, data type synchronization, modulation, demodulation, tone decoding. Next, encoding, decoding, tone decoding services, frequency synthesizers. Next, frequency multiplication and division. Next, SCA demodulators. Then telemetry receivers. Telemetry receivers also we are using. Next, applications. The main applications of frequency multiplication, division. Next, signal regeneration, telemetry receivers and coherent demodulators. These are the main applications of LM565 IC. So applications is frequency multiplication, division, telemetry receivers, signal recognition and coherent demodulators. So these are all about LM565. So in this class we are completed LM565. First block diagram of LM565. The block diagram is 14 pin block diagram. The 14 pin block diagram contains 14 various pins used for various operations. In 14 pin diagram, the last 4 pins like 11, 12, 13, 14 pins are not connected pins or no connection pins, and the remaining 10 pins are working various functions. One is used for negative supply, that is nothing but ground. 2, 3 is used for input, and fourth one is the VCO output, voltage controlled output, like voltage controlled oscillator output, and fifth pin is the input to phase detector from VCO output, input to phase comparator from VCO. Next, here we are using pin 5 phase comparator VCO input. VCO input is given to phase comparator. Next, fourth is the voltage controlled oscillator output. Fifth one is the voltage controlled oscillator input. Fourth one is the output. Fifth one is the input. Fourth one is the VCO output, and here the VCO input will be given to phase detector only. And the sixth one is the reference output. Seventh one is the demodulation output. Eighth one is the external resistor. Ninth is the capacitor. The external resistor and external capacitor for voltage controlled oscillator. 10th one is the supply pin, and the 11th, 12th, 13th, 14th are no connection. This is the block diagram. In block diagram also same, phase detector contains 2 inputs, 2, 3, and also it has the input of VCO, phase comparator VCO input, and VCO voltage controlled oscillator will be connected with VCO output, and it will be also connected with external resistor and external capacitor. External resistor and external capacitor, it will be contains VCO output. The VCO will be given to internal resistance. The internal resistance of here is we are using 3.6 kilo ohms. Next, plus 10 is pin number 10 is nothing but C2 capacitor is internal capacitor. By using of internal resistor and capacitor, that is nothing but RC circuit, we can build a low pass filter. It can work as low pass filter. Next, seventh one is a demodulated output, reference voltage. same phase lock loop, same here also LM565 same, that it will be work for same frequency multiplication, demodulation, frequency division, but it will be mainly consist of comparator and VCO. So it will be the main advantage here we are using highly linear VCO, that is nothing but highly linear voltage on controlled oscillator. The output of voltage controlled oscillator will follows the input signal. Next, phase detector also one important thing. Phase detector is used for good carrier suppression purpose. So it will be used in multiplier, divider, demodulation, frequency division, multiplication. Next here also we are using resistor, external capacitor. The external resistor value will be from 20 kilo ohms to 2 kilo ohms to 20 kilo ohms, and it will be connected across the pin 8, and pin 9 is nothing but external capacitor. Next, low pass filter will be designed by using of internal RC pins. R is nothing but here the internal resistance is 3.6 kilo ohms resistance, and internal capacitor will be connected across the pin 7 to pin 10. Pin 7 to pin 10 is nothing but pin 10 is a supply voltage and pin 7 is a demodulated output. Next, VCO output will be taken across the pin number 4, and VCO input is nothing but it will be given to 5 to phase detector. Next, low pass filter main advantage is it removing the low frequency signals, it removing the high frequency, it allows the low frequency, and it also reducing the noise, high frequency noise. So here we are using two input pins, pin 2 and pin 3. Generally or in practical cases, pin 3 will be connected to ground, pin 2 and pin 5. Pin 5 is the VCO input, will be given to phase detector input. The phase detector which compares the phase difference between input signal and VCO signal. So the produced DC voltage, and it will be proportional to the difference value. Next, the DC voltage is amplified by using of amplifier, and it will be applied through low pass filter and control voltage of VCO. Here the low pass filter work is, here phase detector output is given to amplifier. The amplifier, this is the amplifier. Phase detector is nothing but it consists of input 2 and input 5. So first phase detector, it compares the values of pin 2 input and pin 5 input. Pin 3 will be in practical cases it will be connected to ground. So phase detector compares the input voltage of pin 2 and pin 5. Pin 5 is the VCO input. The produced DC voltage or the difference voltage DC voltage is given to amplifier. So next, amplifier will amplify the signal and it will be passed to low pass filter. Here the low pass filter is there. The low pass filter is designed by internal RC components. So the voltage is amplified and it will be applied through low pass filter to the control input of VCO. Next, the voltage adjusts the output frequency of VCO until it matches the input signal frequency. So the difference voltage will adjust the output signal VCO until it matches the input signal frequency. When the two frequencies are matched, it will be in lock range. Here the phase detector, if the input frequency changes, the output phase detector changes, thereby forcing the VCO frequency, and it tracks the input signal. The value F naught is equals to 0.25 to RT CT hedges, RT external resistor, CT external capacitor. This is the another procedure. Same here also we are applying phase detector. Next, phase detector to two inputs. So one is the VCO input and second one is the input pin. Next, if it all both are same, it gives the 0, or if it will be difference, it will be given to amplify the phase detector. If the two inputs are same, the phase detector provides the output as 0, that is nothing but then 0 state, it is called free running mode, or it will be difference VCO input and in pin number 2 input is normal, difference. So it will be the phase detector will compare the VCO input with pin 2 input. If both are same, it will be in free running mode, otherwise it will be different. So the difference voltage is given to amplifier, and amplifier to next to low pass filter. Next, VCO output will be checked with input of phase comparator, and both inputs are same or both the values are same. VCO output and input of phase comparator will be same. It logs the state. Otherwise, VCO output will be adjust the output frequency until it equals to input signal frequency. The main applications is FSK demodulation, frequency shifting keying demodulation, data type synchronization, modulation, demodulation. Next, frequency synthesizers, tone decoding, multiplication, division, telemetry services, tracking systems. Next, signal regeneration, coherent demodulators. So these are all about LM565. LM565 IC. Next, block diagram, pin diagram, block diagram explanation, pin diagram explanation, and pin diagram different 14 pins and working function of 14 pins. Next, applications of LM565. Next, advantages of LM565. LM565 main advantages, it will be used in FM demodulation. Next, multiplier, frequency division purpose. Next, another applications, another advantages is nothing, it will be used in tone decoding. Next, simple circuit, easy to construct. The main advantages is nothing but just here we are using two components. That main two components is phase detector and VCO. So the VCO is highly linear circuit. The highly linear circuit is nothing but the output which follows the input signal. So this is the all about LM565. In next classes, next we are discussing about 566, VCO 566. So just up to this class we are completed all timer section, timers, timer related information, timers, there are stable multivibrator, monostable multivibrator, timers applications. Next, stable multivibrator block diagram, waveforms, monostable multivibrator block diagrams, waveforms. Next, input output waveforms applications. The next, phase lock loop definition, block diagram, also LM565. In next class we are discussed about next sessions where the remaining topics in this unit is 565 and all 566, 566 IC. Next, definitions, lock range, capture range. Next, free running mode. At the same time, the last topic in this unit also, modulator and demodulator. So the remaining topics is modulation, demodulation, modulation, demodulation, multiplier. Next, clock range, capture range, 566. Thank you everyone.